All right. So anybody have questions? I'm really not even going to go over questions because what we're doing today is more of dividing polynomials with long division and synthetic division. But I just want to look at this graph for a second. Somebody in the other class asked, how do I know which graph is which if I don't know any of the zeros? And I pointed out that all the zeros are basically the same, only they may have different signs. Some of them say +1, -1, +4. Some of them say -4, -1, +1. The only difference between them is these two start up here. So this is end behavior that's positive. So this is a positive graph. This one's also positive. This one has end behavior in the first quadrant. It's down. It's negative. So this one is negative. This one's also negative. These two have a coefficient. The leading coefficient is positive. These two, the leading coefficient is negative. Right? So now you've got to figure out which one goes with which one here. How do I know? Y-intercept. This one's got a +4. This one's got a -4. This one has a positive y-intercept. This one has a negative y-intercept. So that's all that was. Kayla, can I get you to move over here, please? Thank you. I really mean it today, guys. It's Friday, right? We got a 3-day weekend. I know it's rough. Finals are next week. You guys got to keep it together. Okay. Okay, so we talked a little bit about this yesterday. So I have two different polynomial functions here, right, that are factored out. So here's one that's factored out, and here's one that's factored out. This one has a remainder of 0, and this one has a remainder of +5. So compare and contrast them. What does it mean to have a remainder and not have a remainder? Talk. Be ready to share. How about Amanda? What'd your group come up with? Okay. Which one? For the remainder one. Perfect. So we talked about this yesterday, right? If there's a remainder, then the roots, Amanda said they're not on the x-axis. They may not be on the x-axis with this one, but it doesn't necessarily mean that they're not on the x-axis, but you're really super close. It could be something like this. Okay, let's not make a big deal about it. So this one, well, it's a fire alarm, but let's not make a big deal about it. Well, we just had a false alarm about 3 minutes ago. Right. Okay, guys, I don't have time for this right now. Look, it's already gone. Okay, perfect. All right, so this one, it actually is crossing the x-axis, right? But this one is crossing the x-axis. Okay, so, all right, so this one we actually have zeros that are integers. We can actually plot them. These are estimated. They may be decimals or fractions or square roots, right? We can't actually say this one. We know that there's a 0 at -2 and there's a 0 at 2. But once we have a remainder, they're not actually going to be actually on 2 and -2, right? They may be a little bit over, a little bit off, or sometimes they're imaginary, like this one is right here. These are imaginary roots up here. Okay? All right, let's move on. That's a kind of a recap. All right, so this is where we're going today. This is long division. This is what we did yesterday, right? This one is, actually, this is what we've been doing for 2 days. So even if you're absent yesterday, the only difference that we did yesterday is we came up with a remainder at the end. Okay? So if we have a remainder, it means that +3 is not a 0, right? Okay. So why don't you guys take a moment. I want you to look at synthetic as opposed to long division. They're the same exact problems. They have the same exact answers. They have to have the same exact remainders. Okay? So take a look, and I'm going to call on you in just about a minute or so. Okay, can somebody give me something that they see? Okay, Allison? There's no X's in synthetic division, yet there's X's in long division. Good. What else? Okay. Oh, I didn't even look at it like that. This one looks like it's right side up. This one looks like it's upside down. Very true. What else? Philip, is that a hand? Yeah. It looks simpler? Yeah, it's definitely got less up there, right? Allison? Not just the ones underneath. They all do. They're all opposite signs. Can anybody guess why? What? Kellen? Okay, so on this one, each time I drew the line and changed the sign, right? I'm not changing the signs on that one.
Department action, time to staff and students. We are attempting to reset our alarm system, so there may be a few more false alarms. We will notify you when we have the situation under control, and we should expect no further issues. Thank you.
Okay, so there's another thing we're looking at here. Kellen, you've got almost all of it. He said that these are all opposite signs. This one's an opposite sign as well, but we never drew a line and changed the sign for this one. There's another reason. Sarah. I subtracted. I actually just combined them, right? I'm not subtracting or I'm just combining them. But I'm talking about these right here. This is the last thing I really want to get to. Go home. So you're going to want to watch the video this weekend. What else, Allison? If you switch all signs, you're going to get the same answer, yes. But I want you guys to just concentrate on this and this and this. Tristan's got it. You've got it. If I were to say to myself, if I were to give you this, what would you tell me? What would you say you know about that? That my y is 0. Good. And my roots are at 3 and 4. 1, 2, 3, and 4. Right? Okay. So if my roots are at 3 and 4, they're opposite signs, right? So see that? Right here it's being read as x minus 3, but really the 0 is going to be 3. So over here we start off with the 0 being 3. Okay? There's one more thing here. We're going to do that first. We're going to consider, because that's what we're trying to find with division. The reason for long division is to find zeros, right? If we have a remainder, not a 0. If we have no remainder, it's a 0, right? It's a solution to our graph, yes. Exactly. Well, exactly. If there's a remainder, we know that that's not a 0, and that divisor is of no use to us. I guess that's the way I would put it. The divisor, this divisor, it doesn't work. Okay? That's exactly, and we're going to get there on Tuesday. All right, there's only one more thing I want you to see. Do you see that this here is the same as this here? So this is actually, we started with 2x cubed, right? And we ended up with 2x squared. That's the same thing here. This is actually x cubed, x squared, no x, right, or 1x, and then no x right there. So that means this one's going to be not cubed, but squared. So this is going to end up being 2x squared minus x minus 3 with a remainder of 4. Alrighty? Okay. We ready for this? All we're going to do at the very beginning is just set it up. I want to get you guys proficient at setting it up. Okay. So how would you set up the synthetic division problem? The first thing I'm going to ask myself is there any holes? Are there any holes? 2, 1, none. Are there any holes? No. No. What's my 0? -2. So I'm going to put -2, and using synthetic division, we're going to find out if -2 is a 0 of this polynomial function with a coefficient of 2, 7, and 9. Okay? You'll see in a minute. That's how we're going to set each one of them up. I'm going to do another one. Let's find any holes. 3, 2, 1, none. There's no holes. I ask myself, I'm testing to see if -1 is a 0 of my function. So I put a -1, and I'm going to be testing if -1 is a 0 of the function with coefficients of 1, 3, 3, 1. Okay? Can you guys do one? Show me on whiteboards. Just set it up. Set up this one for me. Yes. Good. Another difference is Miss Liz show you that we don't write it with a remainder anymore in a fraction form. Okay, I'll show you. So instead of saying, like, let's say I have a remainder of 2 out of x minus 1, we write it as the whole factored form. So if x minus 1 is my divisor, you would say my polynomial is equal to x minus 1 times whatever your quotient is plus your remainder. And if you actually work it out with multiplication, that works. So you would multiply the two polynomials, or the binomial and the trinomial or whatever, and if you multiply that out and then add the remainder, you're going to get the original. Pretty cool, huh? So. Okay. Ready? Do you need my password? Okay. All right. Can I see it on whiteboards, please? You guys are amazing. Boss group back there. I know, but I want to see whiteboards because I'm trying to go faster. You got almost everybody has a 0, a hole. Almost everybody. We're like 80% right now. Okay. 5, 4, 3, 2, 1. Oh, we're still recording. Okay, so this one is 3, 2, 1. We're missing the x, none. I'm testing to see if -3 is a 0 with coefficients of 4, -6, 0, -3. Try one more. Try this one right here. I want to see if you guys can do this one for me. Yeah, go ahead and erase it. 1. Okay, I'm really impressed. I'm impressed that I didn't have to show almost all of you this. All right, so this one, my 0 isn't 1, right? If I were to set 2x minus 1 up to 0, I would get x equals 1/2, right? You could look at it a different way, too. You could look at it like, okay, if I have 2 x's, I don't want to know about 2 x's. I only want to know about 1x. So if 2 x's is 1, then 1x is only going to be half, right? Number sense right there. Okay, so I'm trying to check on a half as being one of my zeros. So if I'm checking on a half being one of my zeros, I'm going to set this up as Coefficient, let's check for holes first. 4, 3, 2, we're missing 2. 1, none. So my coefficients are 2, -1, 0, -4, -5. You guys ready to play? Remember I had that reference? Okay, I'm not going to go to. Family Feud? Okay. You guys ready to play, right? Okay. That's all we really needed, right? Was that setup. All right, I'm not going to go over steps yet. I just want to do it. Let's just leave this alone. Pencils down. Attentive. Okay. Can I see by a show of hands how many of you would still like to practice the long division piece? Okay, that's good. That's a good half of you. So why don't you guys go ahead. 2, 1, none. This is my dividend. This is my divisor. What am I testing to see if it's a 0? A 5. Good. So why don't I'm going to give you guys about 1 minute to go ahead and try and do that. Shouldn't take, yeah, you don't have to if you don't want to. 1. Okay, so I'm going to do this one quickly so you can check your work. You don't want to erase because you want to see if you got it right. So I'm going to ask myself, how many times does x go into x squared? It goes in x times. Forgot my lines. It goes in x times. I put that in my x column, but I don't want those as lines. X times -5 is -5x. X times x, why am I talking over people? Is x squared. Draw the line and change the signs. This goes away. 8x plus 5x is 13x. Bring down the -3. Then I ask myself, how many times does x go into 13x? It goes in 13 times. 13 times 5 is -65, and 13 times 3 is 13x. Draw the line, change the signs. 65 and -3 makes 62. Now we're going to rewrite this like you should have done yesterday. There we go. Okay, so I'm going to rewrite it as my polynomial function was originally x squared plus 8x minus 3 is equivalent to the divisor of x minus 5 times x plus 13 with a remainder of 62. Now I'm going to set up my synthetic division to check. So I'm going to emphasize tonight, okay? Lucas, can you cap that marker for me, please, so it doesn't dry out? I'm going to emphasize tonight. The first 3 problems on your homework are due side by side. Division, long division, synthetic division. Last night I didn't emphasize on the checks by multiplying. You don't have to check when you're doing it both ways, right? That is a check. If you're doing it long division way and you do it synthetic and you get the same answer, that's a check. But if you, on the back side, you get to pick which way you want to do it, on those you need a check. Now you could use multiplication to check, or you could use the other type of division and check. So either way, I need checks on the back side. Does everybody understand? Turn to your partner and tell them what I just said. Okay. 5, 4, 3, 2, 1. Better. All right, so now I'm going to set up my synthetic division. I'm looking for if 5 is a factor of the polynomial with a coefficient of 1, 8, -3. Now, the reason I draw that line right there is, don't we go from a trinomial to a binomial? Lucas, I need you to look up here and stop talking, please. You're going to have to earn time away rather than the whole class. If you want me to add if you want to join me in Lucas's party after school, then just let me know and I'll write your name up there, or just start talking. Okay, so we went from a trinomial to a binomial. Do you notice that this is a trinomial? When I draw this line, it's going to end up being a binomial. I'm going to show you right now. Okay, so the number one step in setting up synthetic division is figure out what my 0 is that I'm testing. My second is write my coefficients. My third is to bring down. We'll do it with green. I'm going to bring down that first coefficient of 1. Okay? Next thing I'm going to do is I'm going to multiply. 5 times 1 is 5. 8 plus 5 is 13. 5 times 13 is 65. 65 and negative 3 is 62. This is going to be, here's my constant, here's my 1x, but we don't normally write 1x, right? We just write x. Do you notice that it's exactly the same as up here? Okay, do you guys see the parallel here? First we brought down the 1. That gave us my first coefficient in my answer. Then we did the whole 5 times 1 is 5. Didn't we do that here when we got 5? Did we end up with 13x? Did we end up with 13 here? 5 times 13 is 65. Didn't we end up with a 65 here? So it's all the same thing. You're just doing it without all of the variables in it. Okay? The reason you didn't learn it first is because this wouldn't make so much sense if you hadn't seen this first. Okay? And you can't always use this. You can use it a lot, but not always. It helps you in the very beginning to add in little tiny x squared, x, nothing, and this would be x. That's fine, but you're going to get to the point where you don't need that. Okay? All right, I'm going to do another one. Then we're going to talk about our steps, and then we're going to do a harder one. Everybody, okay so far? Thumbs up, thumbs down. Okay, not that you could do it yourself, but kind of the general process is coming through. All right, let's get rid of this. How many of you, thumbs up, thumbs down, want to do another long division real quick? Okay. All right, so I'm going to set this one up using synthetic division. So I'm looking for a factor of -1 or a 0 of -1. So I have my -1 and my coefficients. We've got 3, 2, 1, none, so we don't have any holes. So my coefficients are 1, 3, 3, 1. My first step is to bring down that 1. -1 times 1 is -1. 3 and -1 make 2. -1 times 2 is -2. 3 and -2 make 1. 1 times -1 is -1. 1 and -1 make 0. Is -1 a 0 over a polynomial function? Yes, it is. And if you look really closely, you could see the other ones too. Does anybody see it? You have 2 of them. You have 2 of what? A double root? You actually have a triple root. X, x, 1, and 1. Isn't that x plus 1, x plus 1? Don't we also have an x plus 1 here? So this is actually the answer to this one is x cubed plus, I'm going to make this a lot neater. Let's do this. Okay, so originally it was x cubed plus 3x squared plus 3x plus 1 is equivalent to x plus 1 times x plus 1 times x plus 1, or x plus 1 cubed. What's that look like on a graph? What would x plus 1 cubed look like? Where's my 0? -1. What's my y-intercept? Good job, guys. You guys are awesome because of this right here, right? That tells me what my y-intercept is. This tells, now that I've got it all factored down, I know that it's got 3 there, right? So it looks like that. Okay, thumbs up, thumbs down. How are we doing? Okay, one more? You want me to do one more and then we'll try some on our own? Okay, I'm going to do the hardest one. 2:21. I got 20 minutes. Awesome. How about, no, let's go through our steps. Why don't you guys get some notes out? All right, let's write down our notes. Lucas, now it's going to be longer. Florencia, you guys can finish your conversation after school. Okay, everybody up here? Can I get you guys, I don't want you writing as we're talking. Let's just write the notes down really quick up here, and then you guys can copy them down. How's that sound? So you can copy this example down along with your notes. Okay, so let's talk about it. Number 1, what was the first thing that we did? We wrote the 0. We wrote the 0. We identified a 0, a possible. Identified possible 0. What was the next thing we did? What do we call those? What do we call those? The columns? What do they have in the columns? Not the bound. No. What are these called?